Hello, this is Mrs. Arnold, and in this video, we are going to talk about the scientific method, controlled experiments, and investigations. Questions you should be able to answer at the end of this video is what are independent and dependent variables, and how does experimentation and investigation differ? Before we begin, let's take a look at the following problem. I want you to begin thinking about these questions. We will revisit this slide for you to answer the questions at the end of the video. So the problem is a scientist wants to test the effects of acid on the weathering of rocks. The scientist uses 3 identical rock pieces. The scientist makes observations and records measurements based on the results of the experiment. In your book, you see this chart of the scientific methods. What I want you to think about is, what does this flow chart tell you about the scientific method? What you can see from this flow chart is that the scientific method is not set in stone. There isn't a set method which every scientist follows. And you can also tell that we can return to a previous step in the method. So to illustrate that, let's see, right here, we can see that if our hypothesis is supported, then we repeat the experiment many times until the results are consistent. So we can see that we double back and go through steps in this process. So scientists use similar methods to gather data and communicate information. So the scientific methods is a series of problem solving procedures that help scientists conduct experiments. And of course, part of doing a scientific investigation is forming a hypothesis about whatever problem or question that you have. So a hypothesis is going to be a testable, that's why we're creating the experiment or the test, a testable explanation of a situation that can be supported or disproved by careful procedure. A controlled experiment is a very important part of the scientific method. As we will discuss, the controlled part is extremely crucial. So an experiment is an organized procedure that involves making observations and measurements to test a hypothesis. Collecting good qualitative and quantitative data is important during an experiment. Qualitative data is going to be descriptive. So this is data that you get using your 5 senses is probably the best way to describe it. So some things will be like, how does it smell? What color is it? Those will be some examples of qualitative data. Quantitative data is numerical. So these are measurements. Example here would be getting the mass of the object. Qualitative versus quantitative data. So on this slide, we have some practice distinguishing between qualitative and quantitative data. To test yourself, pause the video here to complete this chart on your own. All right, so after doing that, which do you think is more scientific? Why? Take a moment to write in the box on your notes which one is more scientific and why you think that is the case. And now let's go over the observations. So the first observation we have is it is light green in color. That is descriptive. It is not a measurement, so it is qualitative. Next one is it tastes sour, also descriptive. We have one leaf is 9 centimeters long. That is a measurement, so it's quantitative. It makes a loud pop sound. Qualitative. It's descriptive. The mass of the computer is 1.5 kilograms. That will be quantitative. And we also have it smells sweet. Descriptive. So it's qualitative. There are different aspects of a controlled experiment. These are the independent variable. So this is a factor that is changed by the experimenter. It is also known as the manipulated variable because this is the one that you control. The dependent variable is a factor that is affected by changes in the independent variable. So because you change the independent variable, the dependent variable is responding to those changes that you made in the independent variable. So it is also known as the responding variable because it responds to the changes made in the independent variable. A control is super important. It is used in the experiment to show that the results of an experiment are the result of the condition being tested. So, as I mentioned, this is very important. Let's say you want to determine whether studying with music helps students do better on tests. So you get a group of kids and you have them study with music. At the end of that, you give them a test. But how do you know if studying with music helped? You have to compare their test scores to test scores from a group that studied without music. This group is known as the control group. This way, we can tell whether the treatment, in this case, listening to music, actually improves test scores, or whether or not it had no effect, or maybe it made test scores worse. But you don't know that if you don't have the control group. Next variable that we have in experiments are our constants or controlled variables. These are not to be confused with the control, but these are the variables that you need to keep the same between the control group and the experimental group. So going back to my studying with the music question, the control group has no music. The experimental group gets the music. But what things should we keep the same between them? Should one group be studying for algebra and the other for earth science? No. So maybe the subject, age, academic ability of the students should be things that we keep the same between the two groups. So constants / control variables are variables that need to be kept the same or constant. So variables kept the same or constant between experimental and control groups. Okay, now it's time for some practice in writing hypothesis, finding the independent and dependent variables and control variables and all of that jazz. So our research question is, how does weightlifting affect bone density? So we can write a hypothesis a few different ways. We can say if people lift weights, then their bone density will increase. We can say if people lift weights and their bone density will decrease. So whatever you think will happen, that is what your hypothesis is going to be. Of course, usually researchers formulate their hypothesis after they have done some background research on their question that they have. So then they have a more informed guess, more educated guess. So a hypothesis that we're going to write is that if people lift weights, then their bone density will increase. And so we always want to describe how the independent variable would influence the dependent variable. So in this case, we are saying that it would cause it to increase. So our independent variable, the one thing that you as an experimenter can change is weightlifting. You can't affect the person's bone density. So weightlifting is the thing that you can manipulate. The dependent variable then is whether or not the bone density is affected by that. Then I like to come back to our controlled variables right here and do that after we establish what the control and experimental groups look like. So the control group is down here. This is the group that does not get the treatment. The treatment in this case is the weightlifting. So the treatment is always going to be the independent variable. So this is a group that does not get the treatment. So what we should write is describe who or what we're talking about, who or what's going to be in the group, and who's going to be in this group are going to be people who, let's say, who do not lift weights because they are not getting treatment. And then that means that in our experimental group, we have people who lift weights. These are the people who will be getting the treatment, aka the independent variable. So some controlled variables that we can think of between these people then is probably their age. Maybe make them around a similar age because older people tend to have less bone density. Also, another factor that can affect bone density is going to be the sex of the individual, so whether they're male or female. In some other things that we probably want to control is their diet. You can also probably control the amount of exercise. Next, we have investigations. Investigations are used when scientists cannot control aspects of an experiment. An example would be not being able to control rainfall or temperature when studying the effects of new fertilizer on fields of corn. An investigation includes observation and collecting data, but it does not include a control. And you will use it when you cannot control aspects of an experiment. After you complete an investigation or experiment, it is time to analyze and draw conclusions about your data. So after you complete your experiment, you create graphs, tables, and charts to display your data. And that is a good thing because a lot of times making a graph of your data is going to alert you to trends in that data. So you analyze your data and then you can draw conclusions. Maybe one conclusion that you draw is that as the temperature increased, the how efficient the fertilizer was decreased. It is also important that new ideas are carefully examined by the scientists who discover them and by other scientists in the same field. Things like the process, data, and conclusion have to be examined to eliminate the influence of bias, expectations, and beliefs. Maybe the scientists expected the data to show one thing and it actually shows another, and they don't actually fully realize that. Many times, a conclusion does not support the original hypothesis, and that is okay. Remember, we want to make our hypothesis falsifiable. So when you come up with a hypothesis, you want to design a test, an experiment to prove that hypothesis wrong. If your hypothesis is proven wrong, you want to reevaluate your hypothesis and conduct further research. Excuse me. So if it's proven wrong, you want to reevaluate your hypothesis and conduct further research. This is something that Thomas Edison did when he was trying to make the light bulb. This quote says, "I didn't fail 1,000 times. The light bulb's invention was 1,000 steps." So each time it didn't work, he learned more information on what to try next or how to do it better. I want you to complete this problem on your own on a separate sheet of notebook paper. It will be collected. If you read page 12 of your textbook, you will find a lot of help for this problem. In review, today we learned about the scientific method, controlled experiments, and investigations. I hope after watching this video, you better understand how controlled experiments are structured. We will be doing more practice on hypothesis and controlled experiments in class. Have a wonderful day.